Today's video, we're going to look at practice problems for MTE2, operations with positive decimals and percents. The first problem asks us to write 21 and 56 thousandths as a number. There it is. The last digit has to be in the thousandths place value. That's why there's a 0 there as a placeholder. This is 56 thousandths. The next problem asks us to identify the place value of the 7. That's in 0.4715. That's 7 right there. It is in the second decimal place, so it's in the hundredths. Hundredths with a TH place value. Our third problem asks us to add 9.69 and 1.4. There's an imaginary 0 right here, so we can make the number place values match. 0 plus 9 is 9. 4 plus 6 is 10. Keep the decimal place lined up. 1 plus 9 is 10. Plus another 1 is 11. There we go. You can stack them vertically if you want to, if it makes it easier for you. You get the same answer. Now we're going to multiply 35 hundredths and 2 9/10. I always multiply vertically. We're going to treat this like it's 35 times 29 for right now, and we'll take care of the decimal places at the end. 9 times 5 is 45. 9 times 3 is 27, plus 4 is 31. Slide over here. 2 times 5 is 10. 2 times 3 is 6, plus 1 is 7. Going to add. Now we're going to count the number of decimal places that we see. 1, 2, 3 total decimal places. So we're going to slide over 1, 2, 3 places. And our final answer is going to be 1 and 15 thousandths. Number 5 asks us to divide 52.7 by 3.4. We don't divide by a decimal on the outside, so we're going to multiply inside and outside by the power of 10 that's required to slide the decimal point over to the right. We know from fractions in our last video that we can multiply the numerator, which is the inside, and the denominator, which is the outside, by the same number. That's a unit fraction, and we won't change the problem. So by multiplying in this problem by 10 over 10, we can slide the decimal place 1 place to the right on the outside and 1 place to the right on the inside, and we haven't changed the problem at all. Let's add a 0 here. And we have our answer of 15 and 5/10. The answers are the same between these two problems, so this is also 15 and 5/10. Now we're going to simplify 2 and 4/10 plus 3 and 15 hundredths times, that's a multiplication dot, times 2. Multiplication comes before addition. So this is going to be, which is the same thing as that. I don't need that trailing 0. On to problem number 7. Asks us to round to the nearest hundredth. That's the hundredth place value. So we're going to look at the thousandths to tell us how to round. And we're going to say that this is about 43 hundredths. Now we're to estimate the sum of first rounding each number to the nearest whole number. So this is about the same thing as 8 plus 6. So it's about 14, right? Give your estimate as a whole number. 9 asks us to estimate the product of 3 49/100ths times 7 508 thousandths by rounding to the whole number first. Give the estimate as a whole number. So this is about the same thing as 3 times 8, which is 24. Number 10 asks us to count the small squares below. Just to look at the squares below, 25 of the 100 small squares are shaded. What percent is shaded? Okay, 25 out of 100 is literally 25%. That is what the definition of percent means, is out of 100. So if we have 25 over 100, that's the same thing as 25 hundredths, which is the same thing as 25%. So you know how to switch between fractions, decimals, and percents. Moving on to number 11. 11 asks us to write 5/8 as a percent. So 5 over 8 equals what as a percent? Well, let's divide. I want a percent, so I'm probably going to go to the nearest tenth of a percent. 8 doesn't go into 5 at all. 8 goes into 56 times. It's 48. 8 goes into 23 times. Into 2 times. 2 times 8 is 16. 8 goes into 45 times. So this is the same as 62.5%. See that? Because I'm going to multiply by 100%, which is going to shift the decimal point 2 places to the right. That leaves me with 0.5% there. Okay. 12 asks me to convert 3/16 to a decimal. So this is going to be 1. This is going to be 6. 7. No, 8. This is 48. This is 20. This is 12. Bring down the 0. This is going to be 7. And they don't tell you, but in some of these problems, you're going to have to round. This is going to be one of them. Actually, this is not one of them. We're done here in just a second. So multiply by 5 is going to give me the exact answer here of 80. We're done. So our decimal for 3/16 is 0.1875. Some of these things come up to be repeating decimals. Those are usually things that are divisible by 3 in the denominator. Some things that are divisible by 7. 11 other prime numbers like that. Usually things that are powers of 2 like this are going to terminate. So also things that are divisible by 5 should terminate. Okay. That was number 12. Let's write number 13. 13 asks us to write 83 hundredths as a fraction. Well, we just read it that way. 83 hundredths. There's no simplification that needs to be done. Write 20% in its simplest form. 20% is 20 out of 100. It's going to be the same thing as 1/5 because 20 divides into 100 5 times. Now they want us to write 12.5% as a decimal. That's 12.5% is 125 thousandths. Now they want us to list these numbers in order from smallest to largest. We start off with the list 5, 6, 0.658, 7/10, 0.75. It's usually easiest to compare everything in decimal form. So 5, 6 is going to be, let's see, 6 goes into 8, 23, 18, repeating. Okay, so we have 0.83. And we have 0.658. That bar that I put over top says that it keeps repeating over and over again. All right, so smallest to biggest. So smallest is 0.658. Then we've got 0.7, got 0.75, then we've got 0.83. We're going to change them back to their original forms. So this one started off as a decimal, leave it alone. This one was 7/10. This one was a decimal. That one was a fraction, 5, 6. Okay, that makes sense. This one's very close to 1, right? It's only 1/6 the way. So this one's 1/4 away. 1/4 is bigger than 1/6. This one's closer. Going on to number 17. Number 17 says 30 is what percent of 150? So we got a couple of different ways we can do this. I'm going to set it up with a proportion, even though proportions are really something that we talk about more in MTE 3 because they have an equal sign in them. We're going to say, actually, yeah, proportion is how we're going to do this. So we're going to set up the proportion that says that the amount over the base, like that, is equal to the percentage over 100. So the question word is going to be my variable here. I'm going to call it X. So we're going to say that 30 is what percent of 150. So the base here is 150. That's the number that we're saying. 30 is what percent of that. I know some textbooks like to write it this way. I'm going to write it just because our textbooks do this. This is not my favorite way, but look for the word that's closest to is. look for the word that's closest to of. Those are your amount and your base. And then your P, your percentage, is going to be obvious. It's going to be close to the percent sign, and you're going to put that over 100. So in this case, the question word, what was close to the percent sign? The P is the unknown here. All right, we can go ahead and we can simplify this and say 1/5 is equal to P over 100. I can either change the left-hand side to be in hundredths and find P that way, or I can cross multiply. Let's cross multiply here. 5P is equal to 100. P is equal to 20. Remember that P is in place of a percent. It's 20 over 100. So our final answer is that we are talking about 20%. That 30 is 20% of 150. Mrs. Toner's 5th grade class increases from 16 students last year to 20 students this year. What percent increase is this? So percent increase or percent decrease, you have final minus initial over initial times 100%. So we have 20 minus 16 over 16 times 100% is going to be our formula. This is going to be 4 over 16 times 100% is going to be 1/4 times 100%. 1/4 can be written as 25 hundredths. So this is going to be 25%. There's a 25% increase in this example. We also use that for markup and markdown with pricing. It's the same kind of thing. So we're going to see that in just a second. Local paper mill, the number of industrial accidents decreased from 15 accidents last month to just 9 accidents this month. Find the percent decrease. So I'm going to say that this is 9 minus 15 over 15 times 100%. The fact that this is negative is going to show me that it's a percent decrease. This is negative 6 over 15 times 100%. So let's go ahead and solve this. This is 2/5, which is the same thing as negative 40 over 100 times 100%. This is going to be negative 40%. It's a 40% decrease. Could ask you specifically what the percent decrease is, though. They don't want the negative sign. I'm just showing you that if you use the final minus the original over the original, that the sign is going to tell you whether it's a percent increase or percent decrease. Lots of books are just going to tell you to use absolute value bars around the numerator, to always make it a positive number, and just say increase or decrease at the end. Do whatever your textbook tells you to do. All right. Laptop computer is priced at $650 if there's a 5% sales tax. Find the total cost of the computer, including sales tax. So we need to have a 5% markup. So I need to pay the entire original price, which is 100%, plus another 5% tax. So I need 105% of, let me write it as a percent. I need to pay 105% of $650 is really what I'm being asked for, because I need to pay the $650 base price plus 5% tax to get my retail price this can be 1.05. The word of means to multiply. $650. Let's do that. 650 times 1.05 would be 32. That's a 0 already, so I'm just going to put a 0 in its place value and shift over. 6, 5, 2, 8, 6, and I count 2 decimal places here. So it's going to sell for $682.50 after sales tax. Scott Samuels has pharmaceutical sales of $42,500 last month. His commission rate is 9%. Find the amount of his commission. So his commission is a percentage of the base here. We want to find just 9% of the base price, $42,500. So that's going to be $42,500. 9% is going to be that. 18 plus 4 is 22. 36 plus 2 is 38. And he's going to make $3,825 in commission. For every dollar that he's earning in sales, they're giving him 9 cents. So because he sold $42,500 in pharmaceuticals, he's getting a paycheck of $3,825 for that, called commissions. All right. Bill and Sue Maples borrowed $8,000 for 2 years at a simple interest rate of 18% per year. How much do they pay? So you need to know the simple interest formula. I is equal to PRT. I is the interest accrued on the loan. P is the principal of the loan, meaning the initial amount that they borrowed. R is the interest rate expressed as a decimal. T is time. Make sure that your rate, your percent that you're paying per unit of time here matches this unit of time here. So if this is a daily interest rate, T has to be in days. If this is a monthly interest rate, T has to be in months. This was an annual interest rate. It says per year. So T has to be in years, which we have in the problem. Sometimes you have to do conversions. So I is equal to $8,000 times my interest rate is going to be 18%. I'm going to express that as a decimal. T is 2 years. This is going to be the same as 2. Since this is all multiplication, this is the same thing as 16,000 times 18%. So let's take that 16,000 times that 18%. 0.00048. It's going to give me 128,000. I'm going to slide over another place value, get those 3 zeros from the 3 zeros in the problem. 16,000,882. 2 decimal places, so they're going to have to pay $2,000, $2,880, excuse me, in interest for borrowing this $8,000 from the bank, presumably. So altogether, they didn't ask us this, but altogether, they're going to have to pay back interest plus principal. So they're going to have to pay back a total of $10,880 to the bank for the initial $8,000 they borrowed. You see how that works? The bank is always going to make money off of lending you money. So you pay back more than you borrowed always when you borrow with interest. Pie chart below shows what percent the Johnson's weekly expenses spent on different items, what percent was spent on clothing. So we have clothing was $100 out of their total budget here. We're going to have to add up 100 plus 150 plus 75 plus 50 plus 125, right? So this is 10, 12, 13, 18, 20, 4, 5. It looks like they have a $500 weekly budget. So that is, this will cancel, divide by 100 for both of them. That's 1/5, which is the same thing as 2/10, which is the same thing as 20%. And does that look right that that's about 1/5? That if I have another 1, 2, 3, 4 of those stacked around there, that it would make the whole circle? It sure does, right? Okay. The pie chart shows sales by quarter for Smith Plumbing. The total sales for the year were $360,000. Calculate the sales for the third quarter. So the third quarter is going to be 10%. 10% of my total, 360,000, is going to give me 360,000 times 10%. We know that that's just going to shift the decimal place one place to the left. So this is going to be $36,000. You know, when we multiply by a 10th, it's shifting the decimal place one place to the left. So there we go. Number 26 asks us to use the bar graph below to determine how many juniors are taking the math class if there are 450 juniors at the school. So we need 60% of 450 juniors. So this is going to be 450 times 0.60. It's going to be 270 juniors are enrolled in a math class out of the 450 juniors. A little bit more than half, right? Okay. So next one, using the line graph below, which month shows the greatest increase in sales? Okay, look for the one with the steepest slope, or the biggest change in Y, right? Because these are all the same change in X. So we're looking for greatest increase is going to happen from October to November. So I'm just gonna say that as October to November, right? This line right there is the steepest positive slope. It's the greatest increase. This is 25. This is 26. Now we're going to have to use some conversions. Some of these conversions we're supposed to know off the top of our head. And when we're going from one system to another, to the same system. So for instance, when we go from 7 feet to inches, feet and inches are in the same system. There's 12 inches in 1 foot. So we're going to have to take 7 times 12 and make that 84. When we go in between systems, though, we're going to be given the conversion factor or be asked to use a table. So I'll pull that up here in just a second. So for number 28, it asks us to convert 24 ounces to pounds. So we have 24 ounces. We have, if you just want to see the conversion factor here, we have 16 ounces per pound. So ounces have to line up across from ounces. This is one that you should have memorized, though, because we're in the same system. But this is going to be 24 divided by 16 is going to be 3 halves. 8 goes into there 3 times and into there 2 times. So this is 1.5 pounds. 29 asks us to convert meters to centimeters. Well, that's just changing it by a power of 10. So we're going to move it 2 decimal places to the right. That's going to be 128 centimeters. When we go kilograms to grams, we're going to move it 3 decimal places to the right. So that's going to be 2,600 grams. Now, when we go the other way, when we go from smaller units to bigger units, we're going to have to move to the left, and we're moving to the left 3 decimal places here because we're going from milli to base. So this is going to be 750 thousandths. That's a milliliter is a thousandth of a liter. So 750 thousandths of a liter, or you could call that 75 hundredths of a liter would be fine. You don't need the 0 in the end. Now we're going to use a conversion table to convert 5 quarts to liters. So go 5 quarts to liters. So in our conversion table here. So next page, quarts to liters is right there, 0.94. The top one. So 5 quarts times 0.94 liters per quart. Quarts will cancel. 5 times 0.94 is going to be 20. That's 45 plus 2 is 47. And so this is going to come over 2 decimal places, and we get 4.7 liters, because a liter is just a little bit bigger than a quart is. They're close to the same size. Yeah. So number 33 asks us to use a conversion table to convert 10 centimeters to inches. You all may know this conversion factor already from science classes, but there's 2.54 centimeters per inch. So 10 centimeters times 2.54 centimeters per 1 inch. Have to line the centimeters across from the centimeters like that. So this is going to be 10 divided by 2.54. That's not something that I want to do in my head. I'm going to pull out my calculator here and show you that this is 10 divided by 2.54. It's going to give us about 3.94 inches. And the reason I rounded to hundredths, 10 is an exact measurement, so it has infinite precision. It's exactly 10 centimeters. My approximation here has only 3 significant figures, 1, 2, 3. So I'm only going to give 3 significant figures in my answer here. So that's something for you to learn in science class called significant figures. It tells you how to round. All right, let's go ahead and look at number 34. Says to convert 2.5 hours to minutes. 2.5 hours times 60 minutes per 1 hour, right? Is going to be 2.5 times 60. It's going to be 150 minutes. Number 35 asks us to convert 68 degrees Fahrenheit to Celsius, and they give you the formula that C is equal to 5/9 of the degrees in Fahrenheit, which they told you was 68, minus 32. So C is going to be 5/9 of 68 minus 32 is 36. 9 goes into 36 4 times. So our temperature in Celsius is 20 degrees Celsius. The next problem asks us to go the other way and to convert 15 degrees Celsius to Fahrenheit using the temperature conversion that F is equal to 9/5 C plus 32. 5 goes into 15 3 times. It's going to be 27 plus 32 is going to be 59. All right, degrees Fahrenheit. The last one was degrees Celsius. Okay, number 37 says that we're serving a 10-kilogram turkey to 28 people. How many grams of meat is he given to each person? So 10 kilograms is going to be 10,000 grams that needs to be divided among 28 people. So let's figure that out here. 10,000 divided by 28 is going to be, and we're going to have to round down because we need to have enough turkey to give to everybody. It says to round to the nearest gram. So we're going to give 357 grams of turkey per person.